A short carelessness and it happens. Every year more than 100,000 metric tons of end-of-life waste from electronic and electric equipment, simply called WEEE, are handed over to municipalities and other waste collection points in Austria. For us, the Müller-Guttenbrunn Group, this e-waste is an important source of raw materials for tomorrow's products. Please follow us through our production steps of these sustainable raw materials and gain an insight into our world of e-waste or WEEE recycling. Efficient logistics of the collected e-waste is important. At Müller-Guttenbrunn, we have our own modern fleet of vehicles with the best possible environmental standards. Increasingly important is the transport by rail. And this is why our major plants have an on-site railway station with direct connection to the international rail networks. After delivery, the delivered e-waste materials are checked and released for further processing. The e-waste is fed onto a conveyor belt which feeds the smasher. And this patented MGG invention opens the devices by simulating a fall to the ground. This is an energy-saving way to open the e-waste, allowing to separate individual components that contain substances of concern. Components such as capacitors, batteries and toner cartridges, which are removed from the e-waste. And in addition, we also sort out impurities such as wood and also valuables such as printed circuit boards and electric motors. The remaining material serves as a feed for the subsequent shredding process. This EVA shredder is particularly designed for depolluted e-waste. The 700 horsepower strong shredder size reduces the material within seconds, and this short dwell time is important for the subsequent quality of the recycled plastics. In this process, the various materials are liberated for further processing separations into ferrous and non-ferrous materials. During the process, a large and permanently operating dedusting system cleans the air from the containing dust. The shredded material is passing over Throm magnets to obtain a good quality ferrous scrap, which is checked once again on a sorting belt where the last impurities are removed before it's delivered to the rail to the steelworks. The ferrous scrap ends up in a blast furnace together with the iron ore and thus becomes new steel again. This involves approximately 40% of the e-waste that is turned into secondary raw materials. The remaining coarse and non-ferrous materials are transported to MGG for further processing. The large site of MGG Metran is picturesquely situated on the banks of the river Ips in Kematen. A very large number of different separation processes take place here, all in a well-defined order. Ecology is a very important topic to this facility. For example, rainwater is collected and fed to the individual separation plants working with water. Surface water is collected in our own sewage system that is pre-cleaned in collection basins and returned to the environment after passing through biofilters. LED lighting is on site, as well as solar hot water preparation or the use of electric forklifts, and these are all examples of ecologic considerations that are being used in this plant. As in Amstetten, the transport can be done in an environmentally friendly manner by using the railway network via a specially constructed freight railway station on site. The shredded residues processed by MGT Metran are sourced from the company's own plants as well as from other suppliers in Europe. These are complex mixtures of many non-ferrous metals such as aluminium, copper, brass, printed circuit boards, but also precious metals such as gold, silver, palladium, as well as plastics. The extraction of these non-ferrous metals from the mix requires a combination of different separation techniques. After several sieving steps, the separations combine various technologies using air, optics, induction and other sensor-based techniques. The wet separation forms the heart of the MGG methane separation process. There, some 10 different fractions are obtained from the feedstock. The water table, on the other hand, is a much simpler but very efficient separation technique for separating metallic materials. The dry and fine grain separation plant enables the separation of aluminium and copper. And lastly, sensor-based supported techniques are used, for example, to separate aluminium from printed circuit boards. After the recovery of the non-ferrous metals, a plastic-rich residual fraction remains, which is used as a raw material for the subsequent recycling step at MGG polymers. MGG Polymers, which has been in production since 2006, is specialized in the recycling of e-waste plastics. The facility processes over 50,000 metric tons of these plastics every year. A sample is taken from each delivery in order to determine the exact composition of the load. Then, in the first processing step, the so-called pre-processing, metallic residues, glass and ceramic parts are separated from the waste. The separated metals can of course be recovered and separated. The organic parts such as wood, rubber and fluff serve as feed for thermal recovery. The resulting plastic fraction is size reduced before it enters the following complex separation processes. At the end of the recycling process, the target plastics PP, PS, ABS and PCABS are separated from each other by type. The separated non-target plastics, as well as the plastics with flame retardants or other substances of concern, are thermally recovered in suitable incineration plants. The target plastics undergo a final quality control before they enter large blending silos before being extruded or compounded. The end product is a pure post-consumer recycled plastics in the form of granulates or pellets. These are tested for all relevant rheological, physical and chemical properties before being delivered to the customers. The recycled plastics are finally reused in high-quality products and applications as drop-in replacement for virgin materials. The documentation, packaging and logistics of these plastics produced by MGG polymers are no different from those of virgin materials. Let's follow a delivery of ABS granulates to the world market leader for stamps, Trodat in Wels. We at Trodat place great value not only in the entire production process, but also in the development of our products on the conservation of resources and the environment. How do we do this? As a first step, we make sure that the products we develop are as light and as small as possible. This enables us to avoid CO2 right from the start. For example, the original Printy 4.0, this product was 30% smaller than its predecessor, so a certain amount of CO2 is not emitted in the first place. In a second step, instead of using normal virgin plastic material, we use up to 65 post-consumer recycled plastics from electronics waste, such as housing of computers, laptops, telephones, printers, etc., to manufacture this product. These materials have a significantly lower CO2 footprint than normal virgin plastic materials. As a result, this Printy 4.0 emits as much as 49% less CO2 than its predecessor.